Ladies and gentlemen, welcome. This is our first seminar of 4ST601 statistics in English, and I, Šimpach, will be your teacher during this semester. At the beginning of this seminar, I would like to say to you some important information about me, about my schedule, and about this subject, about our seminar. So, my name is Šimpach. You can see my schedule that I have a lot of subjects this semester. I have exactly 3 seminars of 4ST601 statistics in English, and I try to schedule the office hours. I don't know where you are, if you are at home, abroad, or in Prague, or in the Czech Republic, I don't know. Mainly the office hours will be scheduled personally here at Prague University of Economics and Business in my office, new building 463. In this time and in this day, so Thursday from 16:05 to 18:05 afternoon, but I will be also available for you on email or, for example, on mobile phone if you are not able to arrive to Prague to my office. Yes, so mainly, I prefer office hours here at the university, but you have email, you have telephone, or we have Microsoft Teams, where is chat, for example, so it's possible to discuss some issues online. So this is about the office hours, and now something about this subject. You need to have 13 seminars, yes? 13 seminars in total. This is the first one, and I will send to you every week some materials, yes? Because we must study hard, and you need some study material. So every week you will receive to your school email addresses some Microsoft Excel sheet, yes, where you will find examples, and I will show to you how to solve these examples. So we will practice, and we will practice a lot. Something about organization of these seminars. As you can see, this seminar is prepared in advance for you. This is because I need to use whiteboard, I need to use this projector and the screen, and a lot of other things. I need to write formulas for you, I need to show you steps on calculator in Microsoft Excel, I need to show to you formulas from formula sheet, tables, statistical tables, the values from statistical tables, etc., etc. So I need to use this classroom. Yes, I am at the university in the real classroom, and this classroom is empty, but you are sitting at home and you can see me, and we can simulate the real seminar. Yes, you can imagine that you are sitting in this classroom, and I'm here for you, and I'm trying to show you how to solve these examples. So I will prepare this material every week for you. I will play this material for you in the real time of your seminars, yes, and later this material will be available for you, uploaded on YouTube platform forever. So you can later watch this material infinity times, yes, and study hard at home. I believe that this system will be good for you. I already did this semester ago or 2 semesters ago, because the COVID-19 pandemic is here for many months, yes, unfortunately, and I think that this method is good for you. I believe in this, yes. If you don't like this method, I cannot help you, yes. You can choose another seminar, but I will do this during all semester, yes. So during all semester you will receive from me the 13 real seminars, yes, prepared here in a real classroom, and we will simulate the real situation in classroom at the university. But you will be at home and I will be here. So this is my proposal, and you can accept this and continue with me during the semester, or you can reject this and you can select another seminar. So thank you for your understanding, yes? Okay, so now I will use the whiteboard, and it will be good to say something important about this subject, yes? As I said, every week I will send to you Microsoft Excel with examples. During all semester, it's necessary to use calculator, yes, so have your calculator every time ready. We will use Microsoft Excel in English version. Later I will show to you how to switch on English Excel at these university computers, yes, but at home you have your laptop where you can switch on English language, yes. And we will use other materials, for example formulas, statistical formulas and statistical tables. We can use these formulas either in printed version, yes, or we can use it in PDF file, because we have available computers here in the classroom or at home, yes, so it's necessary to print these formulas and tables. But now I must say to you something about classification, yes. What can I do for you? I will try to learn you statistics, yes, but we must write 2 midterm tests, yes. So Mr. Hellman, the guarantor of this subject, said to you that we will write first and second midterm test in weeks, in academic weeks. This one will be written in 7th week of the academic semester, yes, and the second one will be written in 13th week of the academic semester, yes. This should be the same in all seminars, in case of all teachers, yes. So this is my deal with Mr. Hellman, that we will write these tests. Mr. Hellman prefer personal writing of these tests here at the university. About other conditions and about other circumstances, you will be informed by Mr. Hellman, because the situation about COVID-19 may be difficult in the future, and you will not be able to participate here, to arrive to Prague and write these tests here. Yes, so we know about this, and we will solve this individually with you. So, but now our plan is to write these tests. If the situation will be difficult, you will be informed by many emails, yes, how we solve this situation, yes. But this is the plan at the beginning now, yes. We cannot see to the future. But important information is that every test, yes, is classified up to 20 points. Yes, this one also 20 points. And for the participation at the final test, yes, you need to reach at least 16 points from both of these two tests. Yes, so I can give you maximum 40. Yes, if you will be the best, yes, you can reach 40, but you need to reach at least 16 for the participation at the final test. Yes, okay. My tests, yes, are designed to 3 examples. Yes, up to 8 points, up to 7 points, up to 5 points, so together 20. So 3 simple, easy computational examples based on examples which I can show you during the semester, during our seminars. Yes, so don't worry. Information, other important information about the midterm test writing will be sent to you later in many emails. Yes, so you don't have to ask me now about anything about this, yeah, because we will see. So this is about the tests. Now something important about other information about this subject. So we will start with switching on Microsoft Excel in English language. I will show to you formulas and tables, and after we will start with computing. Okay, so this is university computer. I logged in to the Windows, yes, to Microsoft Windows. And here I have opened the PDF file formulas for 4ST601, yes? So this is the PDF file which Mr. Hellman sent to you, and we will use these formulas during all semester. Yes, so there is a menu of formulas, and during our semester I will practice each formula, practically almost each formula which is written in these papers. Yes. Another important document, statistical tables. Yes. I don't know from which seminar number 4, 5, 6, 7. I don't know it now. Yes. But later we'll start using statistical tables. Yes. So another document. This one, tables for 4ST601, and you can see that we have here a lot of numbers, a lot of values, yes, which is calculated for particular probability distribution. So later we will also use this material. As I already said, every week I will send to you examples, yes, prepared in Microsoft Excel, so you can already download, yes, download this Microsoft Excel document, for example, on your desktop or to your documents. And now we will switch on English Windows, the image of English Windows and English version of Microsoft Excel. Here at the Prague University of Economics and Business, there is a start button on these computers, and we will find in programs, installed programs, VMware Horizon Client. Yes, VMware Horizon Client. We will use our login information to INSYS, Integrated Study Information System. So your username and the password. Yes, username and password to INSYS. And after we will see installed image of English Windows. So now I will do this. So please, you can see that there is start button, yes, and if you scroll down, you will see here the green icon, VMware Horizon Client, yes. So it's almost on the bottom, yes. So I will switch on this program, and now there is necessary to write username. So I will write here my username and the password. Okay, so you can see there is installed Windows 10 English Standard. So you can double click on Windows 10 English Standard. Okay. And within a few seconds you will see English version of Microsoft Windows, yes, and there we have installed English software, for example all Microsoft Office in English language, and here I will show to you how to solve our examples in English, Microsoft Excel, and on the whiteboard, yes, manually, because it's necessary to know how to solve everything in Excel, and also manually using formulas and calculator. Okay, so everything is ready for you. This is the English version of Microsoft Excel, and I have here opened Microsoft Excel sheet, which I already sent to you, and there you can check. We have some examples, some statistical data and instructions. This is statistics subject, so we will talk about statistical variables. Yes, about statistical variables, and these variables, yes, are from some range, and this range can be a range of numbers, yes, or the range of names, yes. So we have here a table, a small statistical table with some variables, yes, and there is written for statistical variables, number of years spent in jail, and gender, assemble a frequency distribution table of absolute and relative frequencies. So this table is in front of you. I will use the whiteboard, and I have printed this table on another board. Yes? So I will demonstrate everything on the whiteboard. So in the real world, yes, we have a population, large population, which is very often denoted by this capital letter N, yes? Population. It's not only population of people, it's, for example, population of prisoners, yes? There is a lot of prisoners in the Czech Republic, a lot of prisoners in all the world, and there you could see that we have small table with only a small sample, yes, small sample which is denoted small n, yes, and this statistical sample in our situation is equal to 8 persons, yes, 8 persons. And on this small sample, yes, we observed 3 statistical variables, yes, 3 statistical variables: number of years in jail, number of cigarettes smoked per month, yes, and gender, if the prisoner is male or female, yes. You can check below this table, yes, that variable number of years spent in jail is numerical variable, yes, numerical variable, ordinal, because we can sort the data in ascending or descending form, yes. Another variable, number of cigarettes smoked per month, is also numerical variable, yes, and also ordinal, because we can sort the values, yes, either in ascending or descending form, yes. And categorical variable is gender, because we have here only 2 categories, male and female, yes. Another categorical variable is, for example, the color of eyes, the color of hairs, yes, etc., where we have a small number of categories, yes. Okay, so what is it? Frequency distribution table. In statistic, we are using frequencies, yes. We are using frequencies Nj, absolute frequencies, and we are also using relative frequencies Pj, yes. Nj is present in our sample table, yes, and Pj, the proportions, can be calculated like very simple ratio Nj divided by n. Yes? So we will use this and we will assemble the frequency distribution table. Okay, so our variable will be denoted xj. Yes. Okay, what first? Number of years in jail. Yes. Which values can be observed in this column? The number of years spent in jail. The values from 1 to 5. Yes. 1 year, 2 years, 3 years, 4 years, 5 years. Yes. Nothing more is presented in the original table. And absolute frequencies Nj, what it means, how many times, yes, is present the particular value in this sample table with our prisoners, yes. So I will check and I can see that there is 1 times presented value 1. I can check that I have here 2 times presented value 2. Value 3, how many times? Only 1 times, yes? Only 1 times is present value 3. Value 4, 1, 2, 3. 3 times value 4 and 1 times value 5 here, yes? There can be written summation through all j. 1 plus 2 is 3, plus 1 is 4, plus 3 is 7, plus 1 is 8. Yes, it's necessary to know that summation through all j of all nj is equal to n. Yes, our sample size, nobody missing in our frequency distribution table. Yes, we can cumulate. Yes. We can cumulate these frequencies. Yes. cumulation of Nj, cumulation of absolute frequencies. 1 plus 2 is equal to 3, plus 1 is equal to 4, plus 3 is equal to 7, plus 1 is equal to 8. Yes? The cumulation of frequencies, we are using, yes, for searching, for example, quantiles. Yes? Later, when we will speak about quantiles, other statistics, yes, we will use this cumulation. Yes? It's just simple cumulation, and you can see in the last row, yes, of the column of cumulative absolute frequencies, you again can see the sample size. Yes? So cumulation of absolute frequencies. Okay. Other important column, yes, in this table is a column with proportions, relative frequencies. Yes? So I will use this formula, yes, and we will calculate Pj. Yes? So how can we calculate these proportions? 1 divided by 8, 2 divided by 8, 1 divided by 8, 3 divided by 8, and 1 divided by 8. If you use your calculator, yes, you will see a result 0.125, 0.250. Again, 0.125, there will be 0.375, and there will be 0.125. So this is a column with Pj, relative frequencies. We can multiply these frequencies by value 100, yes, and interpretation will be in percent. So how many percent we can see here? 12.5%, yes, 12.5% of prisoners spend in jail 1 year. 25% of prisoners in our sample spend in jail 2 years, yes. And we can continue. 37.5% of prisoners spent in jail 4 years. Yes, this is the variable. Yes, this is important. That this is the variable. Yes, and this is the table with frequencies. Again, we can calculate the summation. In your formulas, you have written that summation through all j of Pj is equal to 1.0. Nobody missing. Yes? What is it 1.0? If you multiply this by 100, it's 100%. Yes? 100%. Okay, so here result is 8 divided by 8. Yes, it must be 1.000, 0.125 plus 0.25 plus 0.125 plus 0.375 plus 0.125. Yes, nobody missing. And finally we can do cumulation. Yes, cumulation of Pj, cumulation of relative frequencies 0.125, yes, plus next value 0.25 is 0.375 plus 0.125, result is 0.500 plus 0.375 is 0.875 plus 0.125 is 1.000, yes. Again, here must be, yes, in relative expression or statistical sample, yes. So this is the frequency distribution table for the variable number of years spent in jail, yes. Okay, another variable in this table, the gender, yes. You can check the table in your Microsoft Excel sheet, and you can find here that we have here gender male, 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 female, male, male, female, female. So you can find here 5 males, yes, and 3 females, nothing else. So our variable xj, yes. Now this variable has only 2 possible values, male and female, yes. So absolute frequencies nj, yes. I already said 5 males and 3 females, yes. And that is also possible to calculate summation through all j, yes. 5 plus 3, 8 persons, 8 prisoners in our statistical sample, nobody missing, yes. Okay, so it doesn't make sense, yes, to accumulate these frequencies because we have only 2 rows, yes, so it will not look nice, yes, where I have accumulation only of 2 values, yes. So I will calculate directly proportions pj. Okay, so 5 divided by 8 and 3 divided by 8, yes. If you use calculator, there is value 0.375, yes, and there will be value 0.625, yes, 0.625 and 0.375. We can calculate also the summation, 62.5% plus 37.5% is 100%, 1.000, yes. I already set these values in percentage. Yes, you can imagine that we have here 62.5% and here 37.5%, and very simple interpretation, 62.5% of all prisoners in the sample are males, yes, and 37.5% of prisoners are females, yes. So this is the table, frequency distribution table for variable gender. In our examples in the Microsoft Excel sheet, you have another one variable, number of cigarettes smoked per month, yes. And you could see that this variable, yes, this variable is from range of a lot of different values, yes. It's not the same, like for example situation about the years, the variable number of years spent in jail, yes, but it's different. And you have written here in our examples that we will assemble, yes, we will describe this variable using interval frequency distribution table, yes, interval frequency distribution table. So what's necessary at the beginning? At the beginning, it's necessary to set the number of intervals, yes. Number of intervals. in literature, yes, you can find, for example, Sturges rule, yes, Sturges rule, the formula for the calculation of optimal numbers of intervals, yes, but this rule, this formula is not written in your formula sheet, so we will not use this, yes, we will not use this, we will use our head, our brain, yes, and we will set the number of intervals reasonably, yes, reasonably, individually, yes. So we will deal, for example, that we will set 4 intervals, yes. It's individual, it's on my option. You can also do the same with 3 intervals, yes. Or you can establish 5 intervals, yes. It's very often individual, yes, individual, and here in our subject, in this course, in our seminar, I said that we will select 4 intervals individually, yes. So this is our deal. You have written this in our examples, so we will do this, yes. So we will not use Sturges rule, we will use my decision, yes, we'll use my decision. So I will clean the whiteboard and I will write these intervals, yes, here. So variable xj, number of cigarettes smoked per month, yes. I prepared for you 4 intervals, so from 0 to 149, from 150 to 299, from 300 to 449, and from 450 to 599. What is important? What is important? I created these intervals for you, and these intervals has the same length, yes? This is very important rule, the same length of all intervals, yes? Okay, and second very important rule, each unit from your statistical sample must be placed here in these intervals, yes? So if you check the table, there is nobody, for example, with value 610, yes? Because 610 will not be placed in my intervals, yes? So everybody must be placed in only one of these intervals, yes? You can see value 299, yes, and the next value is 300, yes, cigarettes. So everybody will be placed only in one interval. Okay, so these rules, as we know, and now absolute frequencies Nj, cumulation of Nj, proportions Pj, and cumulation of proportions Pj, yes? So you can check the table, yes? And I can see value 40 and value 132, yes? Value 40 and 132, so 2 values are placed here, yes? From 150 to 299, I can see value 240, yes, 240, and 247. So again, 2 values here, yes. And we can continue. In your table is value 433 and 433, yes. And 346, So 3 values here, and one last observation is here. Yes. So you can see, if you calculate summation through all j, 2 plus 2 is 4, plus 3 is 7, plus 1 is 8. Yes, 8% in your statistical sample. Cumulation, we have here 4. You have here 4 rows, so we can calculate cumulation. 2 plus 2 is 4, plus 3 is 7, plus 1 is 8. Yes. Proportions, relative frequencies. 2 divided by 8, 2 divided by 8, 3 divided by 8, and 1 divided by 8. Yes. So what is here? 0.25, 0.25, 0.375, and 0.125. Yes. Again, interpretation in percentage. 25% of prisoners smoke between 0 and 149 cigarettes per month. Yes. 25% of prisoners smoke between 150 and 299 cigarettes per month, etc. Yes. In this interval, we have placed 37.5% prisoners and 12.5% of prisoners. Yes, we have placed in last interval. Again, summation 1.000. Yes, should be the result, and cumulation 0.25. Yes, plus 0.25 is 0.50. Plus 0.375 is 0.875, plus 0.125 is 1.000. Yes, nobody missing in your table. So this is the frequency distribution table, yes, which we used for this type of variable, number of cigarettes smoked per month. This variable is very close to, very similar to another variable which you know, for example, from some survey, statistical survey. Maybe somebody called to you, yes, by phone, and ask you some questions, yes, and at the end of this survey, yes, there was a question. There was a question about your net monthly wage, yes, about your monthly salary, and the responses, yes, you should place your monthly salary, yes, to some interval, for example, from 0 to 4,999 Czech crowns, yes, from 5,000 to 9,999 Czech crowns, from 10,000 to 14,999 Czech crowns, etc., etc. Yes, and finally there was, for example, 60,000 and more. Yes. So another variable, yes, where it's good to use this sorting to intervals, yes, because both of these variables, yes, you can see that we can observe a lot of small differences. Yes, here in this interval, yes, you have prisoners, yes, with value 433, 433, and 346, yes, and if we add another prisoner, yes, with value 400, yes, will be placed here, yes, but it will not be good for presentation. Yes, it will not be good for presentation if you write here all values, yes, cigarettes, yes, smoked cigarettes, all values 40, 132, 140, I don't know. So this will be xj. You will have here nj, yes, and you will have here values 1 times, 1 times, 1 times, 1 times, 1 times, 2 times, 1 times. Yeah? So this will look strange. Yes, this. So this is the reason why we very often using these intervals. Okay, so we can continue. This is still the same table, yes, our small sample of 8 prisoners, yes, selected by some system, yes, from all prisoners in the Czech Republic, for example, yes, and there is our well-known variable number of years spent in jail, yes, number of cigarettes smoked per month, yes, and variable gender. And now, on the basis of data, yes, which you can see here, we will specify the following measures. In statistic, we can calculate a lot of measures, yes, measures of central tendency, for example, and measures of variability. And today we will start with some very easy, very simple measures of central tendency. So some number, some statistic, which will say to you in one number very important information about this sample. Yes. So we will use the variable number of years spent in jail, yes, and we will find median, we will find the first quartile and third quartile, yes, and after the same we will do for the variable number of smoked cigarettes per month, yes. So, I will use this formula sheet, yes, and you can see that we are here, yes, the first page. If you check the first row, yes, descriptive statistics, and below this, this text you can find PJ, proportions, yes, calculated like nj divided by n. Summation of all absolute frequencies, summation of nj is equal to n. Summation of all proportion pj is equal to 1, yes, so we did this, and now we'll move here, yes, and very important for us will be the formula here, which is universal formula, and the product n times p will be the most important information. Yes, the most important information. Why? I will show to you. Yes. So I will use the screen, and on the next board, yes, I have the data set. Yes. I have the data set, and I have here the variable xj, number of years spent in jail, yes? So the values 4, 2, 1, 4, 2, 3, 5, 4, yes? I hope that I rewrite these values correctly, yes? And these characteristics, these measures, yes, of central tendency, called median and quartiles, yes, must be calculated every time, must be calculated in sorted sample, yes. So this variable must be sorted, yes. And in our situation, we will use sorting, for example, in ascending form, yes, ascending form. So you can see there is value 1. You can see we have here two values 2, 2, 2. Yes, it's simple ordering, yes, sorting, ordering the order, yes. First place, second place, third place, etc. Yes? So sorted values, 2, 2. Value 3 is here only one time, so there will be value 3, value 4, value 4, value 4 is here 3 times. Yes? So value 4, 4, 4, and finally value 5. Yes? So 8 values I have sorted here as in sorted column. So I don't need this anymore. So you can delete this. Yes? And we can write here position. Yes? Position first place. Yes? Second place, third place, yes, fourth, fifth, sixth, seventh, eighth, yes. So position, and there is our sorted table, yes. And what we would like to find? We would like to find median, yes. What is it, median? X 50 with wave, yes. So this is a median, and median, yes, divides the sample to 2 groups. One group, one set of data is below the median, yes, and another set of data is above the median, yes. And in statistic, we are using p-values, and this p-value must be relative number every time. What is it, relative number? Relative number is number from range 0 and 1, yes, relative number. This value 50, yes, in relative expression, yes, value 50 in relative expression must be 0.50, because this 50, this means 50%. 50% because median is in the middle. But for calculation of everything in statistic, we are using not percentage, but relative number, so this, yes. The universal, the general formula, which is written in a formula sheet, is this one. N times P is smaller than ZP, and this is smaller than N times P plus 1. Yes? This is very important for us. So, we know that we would like to calculate, to find the position of median. Yes, so I know that we will use this p-value 0.50. Yes, 50% quantile, dividing, yes, to statistical sample to 2 groups, one below median and one above median. So we are searching for position Z 0.50, yes? And this position is higher than this product. N in our situation is 8%, yes? And this p-value is this p-value. So 8 times 0.50 is smaller than z 0.50, and this is smaller than 8 times 0.50 plus 1. Yes? So where is the median? There is a value 4 is smaller than z 0.50, and this is smaller than 4 plus 1 is 5. Yes? So below the position, between the position 4 and 5 is the median. Yes. So where is the position 4 and 5? Here. Yes. So between 3 and 4. Yes, between 3 and 4. Why between 3 and 4? We have 8 values in a statistical sample, and 8, yes, 8 is even. Yes. If the statistical sample is odd, it's more easy because the median physically exists. Yes, it's in the middle. Yes, and the same number of values are above and the same number of values are below. So if the statistical sample is odd, median physically exists. In our situation, we have even statistical sample, median physically does not exist and must be calculated. So x50 with wave is equal to 3 plus 4 divided by 2. Yes, it's between these two values. So 7 divided by 2 is 3.5 years. So this is the median, yes, dividing the sample to two groups, one below median and one above median. So we can say why is here this value 50. We can interpret this in this way. 50% of prisoners spend in jail less than 3.5 years, and other 50% of prisoners spend in jail more than 3.5 years. So this is interpretation of median, yes? And because this formula is universal, general, yes, you can imagine any p-value which you want, yes? And this is the reason why you would like to calculate first quartile and third quartile, yes? What is it? First quartile. First quartile is denoted like x25, and the third quartile x75. Yes. So, do you know? Can you expect the interpretation of these quartiles? If we calculate the first quartile, we will see the value, yes, dividing the sample to 25% of all values, and the other 75. So we can say that 25% of prisoners spent in jail less than the value of first quartile, and other 75% spent more than first quartile. And the third quartile, x75, we know we have calculated value, yes, and we can say that we know, yes, that 75% of prisoners spent in jail less than this value, and the other 25% of prisoners spent in jail more than this value. So now we will calculate first and third quartile. Yes? So I will delete this, and we will calculate the position. We will find the position What is important in statistic, p-value must be a relative number, so we are searching z 0.25, relative number, yes? So what is here? 8 times 0.25, this is smaller than this position, and this is smaller than 8 times 0.25 plus 1. 8 times 0.25 is 2. This is smaller than z 0.25, and this is smaller than 2 plus 1. 3, yes, in this situation. So between the position 2 and 3 must be placed the first quartile, yes? So between position 2 and 3. So which values we have here? 2 and 2, yes? So x 25 is equal to, again it must be calculated, but now it's easy, yes? Because between 2 and 2, what is between 2 and 2? 2 plus 2 divided by 2 is equal to 2, yes? 2 years. And the interpretation is very easy. You can say that 25% of prisoners in the jail, yes, in your sample, spent in jail less than 2 years, and other 75% of prisoners, yes, spent in jail more than 2 years, yes. And in the same way we can calculate, the third quartile, yes, and the third quartile will be on the position z 0.75, yes, and we will have on the left side above, below 75% and above 25%, yes. So there will be 8 times 0.75, and there will be 8 times 0.75 plus 1, yes. So there will be position 6 is smaller than z 0.75. This is smaller than 6 plus 1 is 7. Between 6th and 7th position you will find third quartile. So I will write here that x25 was equal to 2 years, and x75 is equal to, what is between 4 and 4? Again 4, yes? So 4 years. So again the interpretation is very easy. You can say that 75% of prisoners spent in jail less than 4 years, and other 25% of prisoners spent in jail more than 4 years, yes? Do you remember our median? Yes, our median 3.5, yes? Our calculated x50 with wave, yes? Our calculated median, yes? This value divided the sample to 2 same groups, yes? One below median and one above median. And this is calculated median because the sample is even, yes? If the sample is odd, for example, 9 values, yes? Imagine one more value, 9 values, yes? Median physically exists, yes? You will see 4 values, yes? 4 values below median, the median, and 4 values above median, yes? Median will exist, but now median physically does not exist, it's only calculated, yes, it's only calculated. And the same can we do with another statistical variable, number of cigarettes smoked per month. Okay, so another variable. I deleted the whiteboard, yes, and if you check your data set, you have written here the values, yes, 433, 240, 40, 346, 132, 247 and 589, finally 433. 1, 2, 3, 4, 5, 6, 7, 8. Yes? So this is xj. This is your statistical variable. Yes? And we wanted to calculate median. Yes? We use this formula that P is higher than N times P, this product, and this is smaller than N times P plus 1, yes? Okay, and we would like to find the median x50 with wave, yes? Very often mistake done by student is use this formula directly on the raw data set, yes? The data set must be sorted. Sorted, for example, in ascending form, yes? We are searching for Z 0.50, yes? So, we know that we have N equal to 8, yes? So, 8 times 0.50 is smaller than Z 0.50, and this is smaller than 8 times 0.50 plus 1, yes? So we already know, we can expect that there will be value 4 and there will be value 5, yes? And as I said, very often mistake done by student is to use this directly on this data, yes? Because students say first position, second, third, fourth, and fifth position, yes? This is unsorted document, yes? Student calculate 3, 4, 6 plus 1, 3, 2 divided by 2, yes? 3, 4, 6 plus 1, 3, 2 divided by 2, 2, 3, 9, 2, 3, 9, yes? He or she will say that this is the median, but it's not true, yes? This is not true, because this is not sorted statistical sample, it must be sorted, yes? So, I will delete this. Don't do this, never, yes? It's a mistake. So, I will delete this and I will sort this sample, yes? So, what is necessary to find position, yes? First, second, third, fourth, fifth, sixth, seventh, and eighth, yes? So the first position, this value 40, another value 132, yes? 132. 240, and after 247, yes? After 346, after 400, 433, 433, and the last value, the highest value, 589, yes? 589. Okay, and this original data set will be deleted forever, yes? So we don't have this variable anymore. There is a sorted variable, yes? So there we have order, and there we have value, and now it will be correctly calculated, yes? Median between 4th and 5th position, yes? Median between 4th and 5th position. This statistical sample is even sample, yes? So x50 with wave will be equal to 247 plus 346 divided by 2. The result, 247 plus 346 divided by 2, 296.5. This is the median, and the result is in cigarettes. Yes. You can see that this value physically does not exist. Yes, does not exist in this statistical sample. It's virtual, calculated median. Yes. 2t. Yes, sorry for this. 2t. Okay. But we can interpret this value 50%. 50% of prisoners. 50% of prisoners smoke in this jail less than 296.5 and half cigarettes, and another 50% of prisoners smoked in this jail more than 296.5, 296 and half cigarettes. Yes? So this is the median. And we can calculate the quartiles, first quartile and third quartile, as x25 and x75. Yes. You know that we will use this general formula. Yes. So the left side, 8 times 0.25 is smaller than z 0.25, and this is smaller than 8 times 0.25 plus 1. Yes. And here again 8 times 0.75 is smaller than z 0.75, and this is smaller than this product plus 1. Yes. But we already know that x25 is between second and third position, and x75 is placed between 6th and 7th position. Yes? So I will clean the whiteboard here, and I will calculate these quartiles here. So 132 plus 240 divided by 2, and here on bottom 433 plus 433 divided by 2. Okay, so 132 plus 240 divided by 2, 186. So this is x25, and here x75 75 is equal to 433. Yes, and you know how to interpret these results. 25% of prisoners in this jail smoke less than 186 cigarettes per month, and other 75% of prisoners smoke more than 186 cigarettes per month. Yes. And we can interpret this, 75% of prisoners in this jail smoke less than 433 cigarettes per month, and other 25% prisoners smoke more than 433 cigarettes per month. So we calculated median, we calculated quartiles, and Mr. Hellman, in his presentation, will say to you that we know, for example, deciles or percentiles, etc. Yes? What is it, decile or percentile? You can calculate, you can set, yes, any p-value here, yes, which you want, yes. So deciles, x10, x20, x30, etc. Yes, until x80, x90. Yes, so deciles. Yes, we have here deciles, and we can move and we can calculate percentiles. Yes, percentiles. x01, x02, x03, x04, x10, x11, x12, x13, x95, x96, x97, x98, x99. A lot of options, yes? So deciles, percentiles, yes? And in general, we call everything this quantiles, yes? No quartiles, because we calculated first quartile and third quartile, but this is in general quantiles. In general, quantiles, and you know that you can calculate any p-value of this quantile which you require, yes? The formula is general, so if you have another statistical sample, yes, you can train, you can practice the calculation of any quantile which you want. I already said to you that during our seminars we will use Microsoft Excel, yes? I showed to you a lot of steps on the whiteboard for illustration, and now I will show to you also how to find median and first and third quartile in Microsoft Excel, because during all our 13 seminars, yes, here in the classroom or at your homes, yes, we will use Microsoft Excel, and Microsoft Excel, yes, is possible to use for both midterm tests, yes. It's not possible to use Excel for the final test, written with Mr. Hellman in the lesson hall, yes. That is not possible to use Excel, but during our seminars and during my midterm tests, it's possible to use Excel, and I will show to you that sometimes it's good to use Excel because you can save time, yes? But we must know how to solve everything manually and also in Excel. So there is your table, yes, with our variables, number of years spent in jail and number of cigarettes smoked per month, unsorted, yes, unsorted. And I will write for you here three functions or one function in three different forms, yes, for the calculation of these three characteristics of position or characteristics of central tendency, median, first quartile and third quartile. So I am here in this cell, yes, and I will use equal sign, and I will write here the function quartile, yes, equal sign quartile. This function, equal sign quartile, this one, returns this function returns the quartile of a data set, yes, equal sign quartile returns the quartile of a data set. So if you double click on this function quartile, there is written array and quartile, yes? So we will select the data, we will select array. So please select these 8 values, yes? These 8 values. So equal sign, quartile, we will open the parenthesis, we will select data, and another function, another important argument for this function is to write here either 0, 1, 2, 3 or 4. Value 1 is first quartile, 25th percentile, yes. Value 2 is a median value. Value 3 is third quartile. So I would like to find median, first quartile and third quartile. So that means I will use this function equal sign quartile. I will select the data set 3 times, yes, and the attribute, I will use the attribute here, attribute 2. On the next row, I will use attribute 1, and on the last row, I will use attribute 3, yes? So you can do this at home, yes? You can try it. If you don't know how to write it, use help, for example, in Microsoft Excel, help for functions, yes? So I will write here attribute 2, and I will close parenthesis. Another function here, equal sign quartile, and again array of data, yes, again array of data. So this, and I would like to find first quartile attribute 1. So I will write here attribute 1, close parenthesis, enter. Yes, you can see its value 2. And here, equal sign quartile, array of data, yes, and which attribute 3, third quartile, yes, so attribute 3, close parenthesis. Okay, so you can verify that I did not lie to you, yes? I calculated well. Okay, so this is for today from me almost everything, yes? We only started with statistic. I said to you some important information about me, about this subject. and we tried to learn something from descriptive statistic. I showed to you frequency distribution tables and interval frequency distribution table, yes. And we talked about frequencies, and I showed to you how to find median and some quantiles, yes, some quantiles in general. In this document, in this Microsoft Excel sheet, you have here supplementary data set. We will not work with this data set because there is a lot of observation. Yes, I don't know, more than 400 of observation. But it may be good for you for practicing. If you want, you can use at home this supplementary data set and select, for example, this variable salary. Yes. It's gross salary of some household, yes. So you have here, I don't know, 470 observations, yes, of gross salary of the particular households, yes. So we have here 470 households, and this is variable salary, numerical, yes, ordinal variable. If you want, at home, you can try to assemble, for example, frequency distribution table. Yes, you can set intervals, yes, for salaries. For example, I don't know, there you can see that there is value 27,300 Czech crowns. There is value 103,750 Czech crowns. Yes? So you can set intervals, for example, from 0 to 9,999, from 10,000 to 19,999, from 20,000 Czech crowns to 29,999. Yes, so the length of interval will be, for example, 10,000 Czech crowns. Yes, and you can sort this data set, or you can select only some sample. Yes, you can select only first 20 values. Yes, and practice at home on these 20 values, yes. So it depends on you. There is this data set. I don't require this because it's a large data set, but for your personal practicing, you can use it, yes. It's yours. So that's absolutely all from me. I hope that you will be satisfied by these seminars, by the structure of seminars. You will have the record of all these seminars on YouTube forever. Yes, so you can study more times than one times. And I hope that everything will be alright. So that's all from today. Next week you will receive another document in Microsoft Excel, and you will continue. We will continue with other characteristics of central tendency. Yes, for example, arithmetical means, etc. So that's all for today. Have a nice day and bye-bye.